welcome back. This is Krishna again, and welcome to my YouTube channel, which is AI Martian. And today I'm going to teach you like how to implement all the activation function which I have taught you so far. So far I taught you about Sigmoid function, softmax function, ReLU, Leaky ReLU, 10H. So I never explain in the whole playlist so far like how to implement these no, activation function in our code. So today I will take one example of code which I already have shown you in the previous section on the Google Sheet. So I will take the same example. I will show you how to implement different activation function and what kind of impact we are getting on the output result. I will let you know about that. So stay tuned. Let's go to Google Colab Sheet. Here we are on the Google Colab Sheet, and I already did some coding. This one, you guys can see this. I already have created one neural network where I have used a ReLU activation function. But now you guys should know about it, like how can we implement other activation function, because this is a activation function which is called ReLU, which you guys already know about it, like how to use it, but you guys didn't know how to use Sigmoid, softmax. But you guys can see here, like Sigmoid I have mentioned on the output layer, but how can we use that input layer? So I will let you know these things. Okay, so here we have a ReLU function, Sigmoid function. Okay, now I will teach you like how to implement 10H, then how can you use Leaky ReLU and all. Okay, so I'm going to take the same example, this one. Okay, I'm just copying this. Okay, basically I'm just going to copy each and everything what I have created. As you can see, there are some steps. Step 2, so definitely step 1 should be upper shell. So I'm just copy each and everything. So here I started all the coding. Okay, so I'm just copying everything. Let's go down. I'm just going to make a heading of it, like how can we use the activation function in a neural network. So how can we use different activation function in a neural network. So this is the heading. Now I'm just going to copy paste each and everything from the top, because I don't want to waste time to write this code from scratch, because I already have created this. So this is step 4. See, step 1, load and pre-process the data. So I'm just going to copy this all, scroll it down, put it here. After that, I have to get next code. So scroll it up. Yeah. So I load a breast cancer data set where 2 kind of patients are there. The first who's suffering from breast cancer, and the second who doesn't suffering from breast cancer. I already get this code. Okay. And now I have to split the feature in inside a variable called x is nothing but our feature. Okay, so I have to split them. So that's why I'm just copying this, scroll it down, put it here. Let's go there once again. And I recently copied this. Now I have to get the target also. This is y, and y is nothing but the target. If you don't know where this sheet is available, then go to the description below. Their sheet is also available, sheet link. You have to simply click and you will get this sheet on your computer screen. You can go through each and every line of code. I would request you to practice. So I just copied this. Okay. Now I have to break down the data into two part, that is the training part and testing part, because first whatever data we have, we use some fraction of data to train our model. Once we train our model, then we also have to check whether our model is giving us a proper response or not, and for that we also require testing data set. So where we can get that testing data set? So we will not go to market and do some research, right? So to save our time, what we do, we simply crop some data from the given data set and keep it aside, and when the model get trained, we pass that data to test whether the accuracy is good or not. Okay, because that data is unseen data from my model. Because if my model, let's say, memorizing the thing, let's say it is not happened, but let's say if my model is memorizing the thing, if my model will also see the test data, maybe it will give the exact output. But on unseen data, like once I will deploy this model in the market, there may be a random data will appear, okay, in front of my model. So my model will not able to give a proper response in that case. And that's why, to protect our model from such kind of misleading information, what we do, we simply split the data into two parts. And one part we use to train our model, and the second part we use to evaluate our model, like our model is giving proper response or not. It's simply play a role like unseen data, which the model will get in future in the market. Okay, so that's why we have to split the data into two part. I'm just copying this, scroll it down, paste it here. Let's go up once again. So I just copied this. Now let's move down, and here I scale the data set, because scaling is also required. See, in neural network or in machine learning techniques, whenever we train a model, there are multiple column, which we call feature also. Okay, so the feature value may be vary from one range to different range. For example, let's say there is a small value 0 and there is a bigger value 1 lakh. Okay, so 1 lakh will influence my algorithm much, whereas 0 will not make any changes in our learning. So for that, we have to scale the data between a particular scale, that is 0 or 1. So that's why we convert this these data into a range. Okay, so our model will get a proper pattern from the data set. Okay, so let's copy this. I already explained these things when I was creating this model. So if you didn't go through the video from scratch from the start, I would request you to go from the start of this playlist, and you guys will definitely understand what I'm talking about. One more thing, guys, practice is very important. So if you're not doing practice, definitely you will get a lot of trouble to understand this. So I also use transformed here, like with the same scale, we are also scaling our testing data. So that's why we use transform. I also explained about it. Okay, so I would request you once again to go back. Means it's already there in the playlist. Okay, I would request you to go there. So I copied this now. There I made a note also last time, like when I was creating this model, I mentioned only we implement scaling on features, not on target. We never scale target. Okay, if you're doing so, that's a wrong practice. Okay, so I would request not to scale target. Okay, target is a kind of actual value which we are expecting as an output. Let's say uh, a person have some salary, so we cannot convert salary between 0 and 1, because if we will ask our model to give us an output, it will give me like your salary is 1 rupee, your salary is 50 cent. So that is not something which is acceptable in the market, and that's why we do not scale target. Okay, so never scale your target, always scale your features. Okay, let's copy this again and paste it here. All right. I hope everything is fine. All right. So there are a lot of print I have used. So I'm just removing this print because I don't need this. I don't need this as well. The good practice is to keep our import on the top. These are our import. So I'm just cutting this and pasting it here. Okay, these are our imports. Okay, so always it's a good practice in machine learning or in Python or in coding everywhere to keep your import on the top of your script. This is a script, a kind of a script where I mention each and every line of code. So this is generally called a script. Now I am just going to train this. Everything is looking fine. Okay. If you need, you can also remove this, but I'm not removing it for now because these are comments. Okay, just to understand like what we did in this code. I'm running this code now. So when I will run this code, see, it is working on it. It is working on it, and we will get some out. See, we are getting a lot of training patterns. See, okay, so our model start training itself. Okay. One more thing I have to check, like why I'm getting these kind of output. I don't need these data. I don't need these data, okay? Because this is not the training part. So I must use print somewhere, and that's why I'm getting that values. Let me remove this. See, I have used this print. I also have to remove this one. Okay, let me okay. I think it will be fine now. So I create model from this place till this place. Okay. Means this is my model. Okay. My model code where I'm using a training part. Okay. So the thing is I am using sequential. I have used layers. I have mentioned how many neurons would be at first hidden layer. This is the input neuron. It is around, I guess, 30 because last time I mentioned that. Please go through the video. Okay. This is activation function and this is ReLU. So I'm just training this model once again. Okay, see my model started training itself. Okay, so see in the very first epoch. Now what is epoch? I didn't tell you so far. Even I didn't tell you the backpropagation concept because backpropagation is important. So I will let you know in the upcoming session. This is accuracy in the very first iteration. Okay, epoch is also known as iteration. Sometimes used to people address it by the name iteration. This is the validation loss. This is validation accuracy. Means why this is validation loss, validation accuracy. So this is a kind of a parameter which I have used. Like I split test data set. So test data set I have passed here. Okay. So while training my model, it also evaluating on unseen data. Like from testing data set which I have splitted, it picks some values and test at each layer. Okay, and it give us some loss and accuracy of that testing data. Okay, and at the end when you guys will see, it is giving us 98% accuracy and the loss is 5% on training data. Okay, and on testing data the accuracy is, on testing data the accuracy is 94% and loss is 14%. So this is not acceptable in the market because loss is very high. Okay, so we have to do some sort of you can say pre-processing on this. Okay, so right now I'm not interested in to do so. I just want to show you like how can we implement different activation function and what kind of impact we will get on this. So I used here ReLU activation function. Okay, ReLU activation function, right? So ReLU activation function I'm using at this code. Now I will use, let's say, 10H. Okay, so how can we use 10H? We'll see. So again, I will copy the same code because I don't want to change code. I just want to show you like what impact I will get on the same code when I will use 10H. To use 10H, what I can do, I have to simply mention here 10H, okay? And let's run this shell again. See, it is taking time also as compared to the previous one. See, I'm getting some accuracy here as well, which is 32% initially on the very first round, and loss is 70%. Here on the validation score, validation accuracy also, I'm getting 78% of accuracy, and loss is 66%. Once we go down, we'll see like 97% is the accuracy and 5% is the loss on training data set. Whereas on a testing data set, the accuracy is 96% and the loss is 12%. So it is better result as compared to the ReLU, okay? So if you'll see in ReLU, there was like a 14 to 15% of loss. I can show you, just to scroll up slowly and see. I'm getting here a loss which is 68%, and the accuracy on validation score is 94%. But the training score is high, and training loss is low as compared to this 10H activation function. Okay, here I'm getting 97%, whereas in ReLU activation function, I was getting 98% of accuracy on training data set. Whereas on testing data set, I'm getting here a good result, 9674. So this is a acceptable model we can deploy in the market, okay, in production of any kind of application, so people can use it, okay, because their training and testing score have a very minute difference, and that is acceptable, okay, where the people used to deploy such kind of model where training and testing score difference should not be more than 5%. 5% is also too high, means people used to like 3%, okay, not more than 3% loss should be there, okay. So let's say training score is here, I can see 97%, around 98%, because when I will approximate this value, you guys will think like 0.97 is not 98%. So I already explained you in machine learning or deep learning, 0.98 or 9794 means it is 97.94%, okay. You guys have to understand this. So training score is, let's say, 98% for now, and validation score is or testing score is nothing but the validation score, okay. Testing score is, let's say, 97% to be approximate. So there not much gap, okay. If you will subtract 98% and 97% together, you will get the difference of 1%, which is acceptable in the market. But one more parameter we have to keep in mind, like it should not be, it gap should not be like more than 5% to 100%, okay. Like, that means suppose the maximum accuracy of training and testing would be what, 100%, okay. The maximum accuracy may be this 100% for these two training and testing score. So the gap of maximum score and the existing score should not be greater than 5%. Okay, should not be greater than 5%. If it is greater than 5%, that model is still not acceptable in the market. Okay, for example, if 92%, let's say I'm getting training score, this is my training score. Okay, and testing score is, let's say, 93%. Testing score is, let's say, 93%. Of course, their difference is 1%. Okay, you guys would start thinking like this is acceptable in the market, but I will say it is not acceptable in the market. Why? Because it is like 7%, sorry, 8% less precise. Okay, because its maximum accuracy is 100%. Out of 100, it is only 92%, and out of 100, it is only 93%. Okay, so this is like more than 5% kind of gap from actual to maximum accuracy of the model. So that's why we will not use such kind of model in production. Okay, production means in the market. Okay, so people will use it. Okay, so we are not recommended to deploy such kind of model in the market whose bias, okay, whose bias is such a use value. This is also called as bias. Okay, bias means what? Let's say maximum accuracy is 100%, but you are getting 92%. See, you are getting 92%. So the bias is what? 7% here. Okay, because 100% is the maximum, you are getting 92. So bias is 7%. So it is recommended if the gap is more than 5% from the maximum and existing score, the bias is high in that case. Bias is high. 1 second, let me rewrite this. Bias is high. It's totally on machine learning engineers that like what they are expecting, what is their requirement. Okay, so this is not acceptable in the market. Again, let's use some other activation function. Like how can we use Leaky ReLU? Because I already have shown you the ReLU. So this time I'm going to use Leaky ReLU. Leaky ReLU. So how can I use Leaky ReLU here? So let's see, Leaky ReLU. I have to call Leaky ReLU first because this is belongs to hidden layer. Okay, so where I have a layer kind of module, it's already there with dense. I will separate it by a comma. Leaky ReLU is there. So I have to remove this and I have to use Leaky ReLU here. And remember I talked about alpha in Leaky ReLU. So that alpha value you have to define here. Let's say I'm defining 0.1. So whatever the alpha means we are getting here, that multiply with the x. Okay, and it will give us the output. Let's run this, and when you will run this, it will start training the model once again. And I'm training my model. See, I'm getting the output. Okay, and this is the output. Now see, I'm getting better result here, 98.33%. Loss is 6%. Validation accuracy is a bit poor. Okay, 93%. And validation loss is also 14%, which is same as ReLU. Okay, so this model is good according to training accuracy wise, but not with testing accuracy wise. There is a huge gap. Okay, the variance is high. Variance means what? What is variance? I will teach you these things. Okay, I will teach you these things. Variance means what? Suppose this is my training score and this is my testing score. Okay, so the gap between these two called variance. Okay, so gap between these two called variance. So there are some threshold value people is assume in the market. Okay, So machine learning engineer, deep learning engineer, make some threshold value in their mind. Let's say they assume, let's say I am a machine learning or deep learning engineer. I'm saying if the score, training score and testing score and testing score difference is greater than 5%. It's a mathematical expression now. So greater than 5%. In that case, I will say variance is high. Means if the difference of these 98% minus, this is training score. See, this is my training score. This is my testing score. Okay. 93%. If you will subtract this and this is greater than 5, in that case I will say variance is high. So this is the threshold value assumed by me. Okay, so if I will subtract this, I will get 5% is greater than 5%. Now what I will say in this scenario, no, the variance is not bigger. But let's say one more deep learning engineer saying if training score and testing score greater than 3%. Okay, if these values greater than 3%, then variance is high. Variance high means that model is not acceptable in the market. Okay, we cannot use that model in deployment. So training score, let's say this time again 98% and testing score is 93%. So if you will calculate the value of this, you will get 5, and 5 is of course greater than 3. So now tell me, according to this machine learning or deep learning engineer, is the variance is high or not? Of course, variance is high. Variance is high. That means what? It is not acceptable in the market. We will not use this model in the market, okay, in the deployment. But according to this deep learning engineer, machine learning engineer, it is acceptable in the market because this is 5 is not greater than 5, but 5 is equal to 5, right? So these model is acceptable in the market according to this deep learning engine. Why such kind of difference there we have? It is totally on our assumption what we are assuming, but it is recommended a maximum threshold value. So maximum threshold value is 5 itself, or you can say 10% itself. If the variance is more than 10%, that model is not acceptable by the market. Okay, this is the maximum threshold value people recommend while training their model. Okay, so they also define this value. They recommend something like if the variance is more than 10%, in any case none of the deep learning engineers should recommend this for deployment. Okay, so they made such kind of hypothesis for us. Now let's use some more activation function, which is sigmoid. I'm going to use sigmoid this time. Okay, but I already have shown you like how sigmoid can use, like, because they're already sigmoid, but this is at outer layer. Okay, see, this is our neuron. Okay, this is our, let's say, neuron. This is input layer. Okay, this is hidden layer, and this is output layer. Okay, so here I'm using sigmoid right now, but I am teaching you like how can we use all activation function at the hidden layer. Okay, so how can we use activation function sigmoid at hidden layer in each neuron? So that thing I'm talking about, and that's why I have to use sigmoid somewhere, this place. Okay, I can use. Okay, so let me let me mention here sigmoid. So how can we do this? I have to simply mention sigmoid. Let's run this. That's it. This is the only thing you have to do. See, I'm using sigmoid. Okay. When I'm using sigmoid, my model is training itself. See, and I am getting 96% of accuracy and loss is very much. Means sigmoid is not a good choice at hidden layer. Okay, for now. Whereas on validation score, it is giving me 99% of accuracy, which is absolutely acceptable in the market. But again, loss is very high in both the cases. Okay, this is the most suitable model we have to deploy. But because loss is also high, see, we have to make some coordinations. The uh, accuracy, training accuracy, testing accuracy should be higher, and losses should be lower. Okay, in both the cases. But here the accuracy is perfect. We can deploy it in the market. Okay, but losses is not perfect. Okay, there are more than 10% of gap we are watching here, right? So this is not acceptable in the market. Okay, now I have shown you all activation function. I cannot show you softmax because softmax always use at output layer. Okay, I have explained when I was talking about softmax, so I would request you to go to my softmax lecture. And this is my Leaky ReLU training. Okay, so let me make a note of it. Okay, this is first of all ReLU. Okay, so let's see what ReLU training testing validation score. Okay, so let's say this is my ReLU and layer. Okay, there's one more step, okay, to find accuracy, but I just want to show you each and everything, and that's why I'm copying this. Okay, this is ReLU. Okay, now after that I use Leaky ReLU. Okay, so let's see what is the Leaky ReLU uh maximum. Oh, shit. 1 second. This is a Leaky ReLU maximum result we are getting. Okay, after that I have to use 10H. I have to use 10H. Let's see what is the accuracy of 10H at a maximum epoch. And at the end, I have used sigmoid. This is sigmoid. Okay, sigmoid. Now, see which one is acceptable. So when we go with ReLU, the accuracy is 98% on training data. Okay, so let me make a note of it on the top. This is training score. Okay, this is training loss. Okay, this is testing score. Okay, this is testing loss. So let me split it first. Okay, See guys, which model is acceptable? So there are various parameters, but for now, just to not make it more complicated, I would like to tell you like this model is very much accurate. We can use it for deployment. Now, what are the parameter behind? I can explain you further, but not in this video, okay? Because this video will become very lengthy now. So this model I can use, 10H model I can use for deployment, because the losses is less here, but here the losses is high, okay? Now we have to see all the parameters, okay? But here the losses is high, okay? So we have to a little bit fine tune our model. But on safe side, if you guys want to go, you can go with this model as well. Okay. If you don't want to fine tune anymore, you just want to deploy it, you can use this because the loss is constant in training and testing, both the cases. And bias is also less here. Okay. And variance is also less. Okay. Bias is what? Once again, bias means what? Let's say accuracy is maximum accuracy is 100%. Okay. So training score, when you will subtract a training score out of 100, it should not be greater than 5%. Okay. Should not be greater than 5%. It always should be less than 5%. Okay. Now, what is variance? The difference between training score, and testing score. The difference between training score and testing score should not be greater than 5%, according to me. Okay. So this is bias, this is variance. Make a note of these kind of things, okay? Because these are very much important. See, this is the maximum score, 100%. If we will subtract a training score out of this 100 and we are not getting greater value than 5, the bias should be low, means this is acceptable in the market. Okay. If this condition is satisfied, what we called low bias, and this is acceptable in the market. Okay. This is acceptable in the market. Whereas variance, if we'll subtract these two, training score and testing score, okay, and it is smaller than 5, okay, so it is called low variance. This two parameter when come together with low values, that model is acceptable in the market. So this is all in this video, guys. If you really like this video, please do like, share, subscribe, share with your friend families, and let me know in the comment section if you're getting any kind of problem. You can also join me on Instagram, Telegram channel I have given in the description, and my WhatsApp group also. So please do join and keep learning, keep exploring. Thank you guys. Thank you very much.